Good evening, my dear students. Today we are going to study about the size of DNA helix. That means in this session, we particularly deals about how to calculate the length of DNA. For the length of DNA, we need two parameters. One is total number of base pairs in DNA is equal to. Then second is distance between two consecutive base pairs. So two variables are required here. The total number of base pairs in DNA is 6.6 into 10 to the power of minus 9. Here, what is the distance between two consecutive base pairs? 0.34 into 10 to the power of 9 meter. So, now how to calculate the total length of DNA? The product of total number of base pair, that means the total length of DNA is equal to the total number of base pair into distance between two base pair. Now you know the total number of base pair is equal to 6.6 into 10 to the power of minus 9 into distance between two consecutive base pair is 0.34 into 10 to the power of minus 9. Now when you multiply this one, the answer meter, the answer comes as 2.2 meter. So the length of DNA is equal to 2.2 meter. Suppose in E. coli, you know about E. coli. The E. coli the total length of DNA is equal to 1.6 millimeter. So, what is the number of base pairs? Total number of base pair in DNA is equal to what? Then next we know the standard value. What is the distance between two base pair is equal to 0.34 into 10 to the power of minus 9 meter. Now let us apply these value to this formula. You know the total length of DNA is 1.6 millimeter in E. coli. So 1.6 into 10 to the power of minus 3 meter by 0.34. Just you shift this this distance between two consecutive base pair to left hand side. So here hence 0.34 into 10 to the power of minus 9 meter. Here meter cancel. Minus 9 goes to plus 9. When you multiply this, when you divide this one, 4 into 10 to the power of 6. So the total number of base pair in E. coli is 4 into 10 to the power of 6. Now, let us have one important concept here. You know the mammalian cell is having nucleus. The size of the nucleus is less than 10 power 6 meter. So, here what would happen? What is the size of DNA? 2.2 meter. So, how this 2.2 meter DNA is packaged in the nucleus which is of lesser size? So that is what, for this purpose only we are studying about the size of DNA helix. How the length of DNA of 2.2 meter is packaged into the nucleus. So this concept leads to packaging of DNA helix. So I hope you understood this concept and what is the purpose or significance of studying this concept. This concept ultimately leads to packaging of DNA helix, which we will be going to study next session. Thank you.